Finding trig values using identities. Okay, we have two trig ratios given here for angle x. We want to find the other four, giving exact simplified answers. As long as you have two and they're not reciprocals of each other, this is not very difficult. When I see cotangent and sine, my mind immediately goes to one of the quotient identities. The quotient identities are perfect when you have two of those three ratios. Now obviously I have cotangent, so I'm going to pick the one that says cotangent x equals cosine x over sine x. I have cotangent, I have sine, I just need to find cosine x. Now I have a couple of choices here. I can either take this identity and algebraically manipulate it so that cosine x is by itself the one I want, or I can put the ratios in now and solve for cosine x. It doesn't really matter. This one looks appealing to me to go ahead and just manipulate it a little bit. If I multiply both sides here by sine x, then on the right the sine x's cancel and I basically have what I want. I have cosine x equals sine x cotangent x. Great. Well, I have those two ratios, so I can just plug them in and get my answer. I'll fill in negative 2 root 10 over 7 here, and then negative 3 root 10 over 20. And let's see, on the top I end up with a 6. Negative 2 times negative 3 is 6. Root 10 times root 10 is just 10. I think I'm not going to multiply out yet. See if I have any common factors. I'm going to have 7 times 20 on the bottom. Sure enough, 10 goes into 20 twice, so I can divide out a 10. And then after that, I see that 2 and 6 share a common factor, so I'll divide top and bottom by 2. I think everything's done now. I'm left with a 3 on the top and a 7 on the bottom. So there's my value for cosine x. I'll start listing the answers over here. Of course, once I have that, the rest of them are just simple reciprocal relationships. Secant x would be 7 over 3. Cosecant x would be the reciprocal of sine, so 7 over 2 root 10 with the negative. Let's see, I'll rationalize the denominator for a final answer of negative 7 square root of 10 over, let's see, 2 times 10 would be 20. 7 and 20 don't reduce, so there would be that final answer. And then the last one would be tangent x. That's going to be the reciprocal of cotangent, so don't forget the negative, and then 20 over 3 root 10. Rationalize the denominator. Let's see, root 10 times root 10 is 10. So this part makes a 10, but I can see that 10 is going to divide out with 20, leaving me with a 2 here. My final answer is going to be negative 2 root 10 over 3. Well, let's go ahead and try another one. This time we only know one of the trig ratios. So we have tangent theta equals negative 7. We want to find all the other 5 using identities, again giving the exact simplified answers. Now we are given one other piece of information, and this is significant. Without this, we would not be able to work this problem. Why are we being told this? Well, really just for one reason, and that is so that we can know what quadrant we are working in. Tangent is negative. Let's see, all students take calculus. We know, therefore, we must either be in the second quadrant or the fourth quadrant. Tangent is positive in the other two quadrants. Well, to narrow it down, we're being told we are in a spot where the sine function is positive. That's right here in quadrant 2. So I know I'm working in quadrant 2. Watch how that fact becomes important. Now, where am I going to start here? I don't have enough information to start with one of those quotient identities. I want to get there, but I need to know at least 2 of the ratios to use one of those. All I can do here is to use one of the Pythagorean identities. And you're going to pick the one that matches the information that you have. I was given the tangent function, so I'll use this one. Tangent squared theta plus 1 equals secant squared theta. I'll plug in the ratio that I know, which is the tangent ratio. Remember, this means the entire tangent ratio being squared. And then I'll solve this for the other ratio, for secant theta. It's actually pretty easy. The left side here is just a number. Negative 7 times negative 7 is 49, plus 1 is 50. In case it helps, you can always rewrite this indicating what it actually means. This is the entire secant ratio being squared. If I want to solve for it, I'm going to have to undo the squared, which I do by taking the square root of both sides. Just remember, though, there are always two solutions algebraically when you do that. I think I'm going to flip this around the other direction too while I'm at it. What I end up with here is secant theta equals plus or minus the square root of 50. Let's see, 25 goes into 50, so I can bring out the square root of 25 as a 5, and I end up with plus or minus 5 squared of 2, since 25 times 2 made 50. We're not saying here that there are two answers for secant theta. That's impossible. There's only one answer. Algebraically, we've written down the plus or minus. That's what you should do to indicate the algebra. Now you're going to choose between the two based on the quadrant. We're in quadrant 2. Well, only sine and, of course, then cosecant are positive in quadrant 2. Secant goes with cosine. Cosine is negative in quadrant 2, so I will choose the negative. My final answer for secant theta is negative 5 square root of 2. The Pythagorean identity is the messiest of these identities, so you should only use it once in any of these problems. Once you have two ratios, you're thinking quotient identity. Now the quotient identities involve sine and cosine, not secant. So what I'm thinking is I need to go ahead and find the reciprocal of secant, get the cosine function. It's just going to be negative 1 over 5 square root of 2. I need to do some rationalizing, and I end up here with negative root 2 on the top, and let's see, 5 root 2 times root 2 would make 2. 2 times 5 would be 10. So there's my answer for cosine theta. But see, now that I have tangent theta and I have cosine theta, I can immediately go to one of those quotient identities. The one that I should pick is the one involving tangent theta. Tangent is sine over cosine. Let's see, I'll do it the other way this time. I'll just fill in the numbers now, and then I'll do the algebra. Either you're going to do the algebra at the beginning, or you're going to do the algebra at the end. Sine theta is what we don't know. Cosine theta is negative root 2 over 10. Okay, I want to isolate sine theta. It looks like I just need to multiply this side by negative root 2 over 10, which means I'll have to do the same thing on the other side. On the right, the fractions have now canceled. And on the left, let's see, a negative times a negative is a positive, so those plus out, and I end up with 7 root 2 on the top and 10 on the bottom. So sine theta is 7 root 2 over 10. Okay, we've collected 3 of them so far. Secant we have cosine, we have sine over here, we were given tangent. We need 2 more. Once you get down to the end, it's just all about reciprocation. Obviously, the cotangent ratio I could have written down at the very beginning. That's just the reciprocal of negative 7, which is negative 1/7. And then the last one we need is cosecant. That's going to be the reciprocal of sine, so 10 over 7 root 2. And a little bit of rationalizing. Let's see, root 2 times root 2 makes 2, and that 2 will divide out the 10 for a final answer of 5 root 2 over 7. The pattern we used is a good one. We used a Pythagorean identity first, then we moved on to a quotient identity, and we found the rest using the reciprocal identities. We expected the sine ratio and therefore the cosecant ratio to come out positive. Sure enough, that's happened, and all the rest are negative. Thanks for watching.